right, let's take a look at a theorem and prove that the theorem is true in our usual way. So here's the given. The given is that AB is congruent to AC. And we want to prove that BD is greater than CD. So the length of the segment BD is greater than the length of the segment CD. Let's take a look at the picture. So here's the picture. And we're told that AB is congruent to AC. So that means that AB is congruent to AC. Okay? And we want to show that BD, that length, is greater than CD, that length. Now, it looks that way in the picture, but that's not enough for the proof. We need to think of a mathematical argument. Well, notice that both triangles actually share a common side of AD. This is interesting. So I've got this side congruent to that side, and they both share this. So what about the corresponding angles? Well, what I see here is that this angle can be thought of as the sum of this angle plus that angle. So therefore, the sum of those two angles equals this entire angle, which means this angle right here, this little wedge, has to be strictly smaller than this one, since I have to add on this measure in order to get the entire thing. Well, since this is a smaller angle than this entire thing, then I know by the hinge theorem this is going to be a smaller side length compared to its corresponding side length here of this one. That is the idea of the proof. Let's make it rigorous. So, we've got some statements, we've got some reasons, and we want to see how all this plays out. The first statement is just the given, which is that AB is congruent to AC, and that is just the given. So that's no problem at all. Up next is this standard reflexive property that AD is congruent to itself. And so what I see here is the reflexive property of congruence working for us here. Now, what was the next thing we noticed? The next thing we noticed is that angle DAB, that big angle right here, the measure of that is actually the sum of the measures of DAC plus CAB. And that's just the angle addition postulate. Make sense? And so, therefore, we conclude that the big angle, the measure of angle DAB, has to exceed the measure of angle DAC, because that measure was required to be added to something else in order to get the whole. And so remember, that's just the comparison property of inequalities. And so where do we go from here? Well, from here, we conclude that BD, that length, is greater than the length of CD, and the reason is the hinge theorem. Once I have that the measure of this angle exceeds the measure of this angle, then I know that the opposite sides are going to behave in a similar way, namely that this length is going to exceed that length. The hinge theorem, yet again, allows us to make a new insight into geometry. In this case, it allows us to prove this little result. Very cool. I'll see you soon.